You know, whenever we talk about these giant AI models, our minds immediately jump to the GPUs, right? The raw processing power. But what if the biggest thing holding them back isn't the brain, but the nervous system, the plumbing connecting everything? Well, today, we're going to uncork a critical bottleneck in AI with a pretty groundbreaking piece of technology.
Okay, let's kick this off with a number that's, well, it's pretty staggering. According to data from Meta, a full 30% of the time spent training an AI model is just wasted. Think about that. It's not spent computing, it's not learning, it's just waiting for the network to catch up. That's almost a third of the time, the energy, the money for these huge projects just vanishing into thin air.
And look, this isn't just some minor annoyance. It's a massive wall blocking progress. As these AI models get bigger and more complex, this network problem, it just gets worse and worse. So, the big question, the one we have to answer, is how in the world do we fix it? All right, so before we can solve the problem, we've got to understand it, right? So let's dive in and take a closer look at what's really going on with this AI networking bottleneck. It really comes down to three main culprits. First up, you've got poor link utilization. Basically, we have these massive data highways, but we're not using all the lanes. Then there's congestion. And yeah, it's exactly what it sounds like. Digital data traffic jams. And finally, packet loss. This is where tiny little pieces of information just get dropped along the way, and that causes some major delays. Okay, so we've laid out the problems. They're big, they're complicated. Now let's talk about the solution. And it comes in the form of a purpose-built piece of hardware called the AMD Pensando Pollara 400 AI NIC. Now, this thing isn't just your average network card. Not even close. The Pollara 400 is special because it's the industry's very first AI network interface card, or NIC, built from the ground up for a brand new, super high-performance standard called the Ultra Ethernet Consortium, or UEC for short. And when you look at the specs, they are all about one thing: pure, unadulterated speed. We're talking a mind-blowing 400 gigabits per second of bandwidth. But here's what really makes it a game changer. It's got a fully programmable hardware pipeline. This gives it this incredible flexibility. And it's all laser-focused on one main goal: slashing the time it takes for an AI job to actually finish. So, you're probably wondering, how does the Pollara 400 actually pull all this off? To get that, we've got to pop the hood and look at its programmable core. It's something called the Pensando P4 architecture. The key idea here is this programmable pipeline. And honestly, the best way to think about it is like a super smart assembly line, but for data packets. See, a normal network just shuffles packets from point A to point B. But this pipeline, it can actually look at the data, analyze it, and intelligently manage the entire flow of traffic, all in real time. It's a traffic cop, not just a row. So a single data packet's journey is incredibly fast, but it's also super methodical. First, it arrives and gets parsed. That's just a fancy word for being broken down for a quick inspection. Then it zips through a bunch of processing stages where custom rules are applied. This is where the real magic happens, right? The NIC makes these smart decisions about routing. And finally, it gets put back together and sent on its way. All of this happens in a tiny fraction of a second. And this new architecture brings some absolutely crucial upgrades. Take atomic operations, for instance. These are designed specifically for AI workloads. They let the card handle the millions of tiny, constant data updates that AI models need, but without ever slowing down. And then there's pipeline cache coherency. You can think of this like a perfect sync system. It makes sure every single part of this high-speed assembly line is working with the exact same up-to-the-nanosecond information. It basically eliminates any chance of data confusion. Okay, so that powerful architecture is awesome in theory, but how does it actually fix those real-world problems we talked about at the beginning? Let's connect the dots. All right, first up, poor link utilization. The old way of doing things, called ECMP, it's kind of like having a 4-lane superhighway, but forcing all the cars into just 1 or 2 lanes. It's just inefficient. The Pollara 400, on the other hand, uses something called adaptive packet spraying. It acts like a brilliant traffic controller, intelligently spreading the data across all the available lanes to make sure not a single bit of bandwidth ever goes to waste. Next up, congestion. AI models are famous for creating these sudden, massive bursts of traffic that cause epic data traffic jams. So the Pollara 400 prevents this like one of those futuristic traffic management systems. It's constantly measuring the round-trip time, basically how long it takes a signal to go out and come back. It uses that info to sense when a jam is about to form, and then it dynamically reroutes traffic to prevent that gridlock before it can even start. It's proactive, not reactive. And finally, let's talk about packet loss. When a tiny packet gets dropped, traditional systems freak out. They often have to resend a whole giant chunk of data, which is incredibly slow and inefficient. The Pollara 400 is way smarter. It uses a system of selective acknowledgements to pinpoint exactly which packets were lost, and then it resends only those missing pieces. It's really the difference between having to ask someone to repeat a whole story versus just asking for the one word you missed. Now, I've mentioned the UEC a couple of times, and it's a really important piece of this whole puzzle. The Ultra Ethernet Consortium is basically a big team-up of industry players. They're working together to create an open standard to evolve good old Ethernet so it can handle the insane demands of AI. It's all about building a better, faster, and more reliable foundation that everyone can build on. So, what's the big payoff for being the first card built on this new UEC standard? Let's get to the good part, the results. And honestly, the results here, they kind of speak for themselves. What we're looking at is a comparison between the new UEC standard the Pollara uses and the old standard, which is called RoCv2. And the difference is, well, it's not subtle. That bar on the far right shows the UEC-ready approach delivering a huge performance jump. We're talking up to 1.4 times faster. And just to put that into perspective, that translates to a 40% performance gain in a supercritical AI communication pattern known as an all-reduce. In the world of AI training, where every single percentage point counts, a 40% gain isn't just good, it's absolutely massive. And this really gets to the heart of why this all matters so much. The USC's mission is all about building an open, high-performance foundation for the entire AI industry. So the Pollara 400, it's not just a product, it's really the first major step in making that mission a reality. So let's wrap this all up. We started with a huge problem, right? AI networking is a massive bottleneck, wasting as much as 30% of precious training time. The solution we've looked at is the Pollara 400. It uses its smart, programmable P4 pipeline to tackle those core issues head-on: bad utilization, congestion, and packet loss. And the result? Because it's the first card built for the new UEC standard, it delivers a really significant performance boost. Which leaves us with one final big-picture question. For years, the network has been the weak link in the chain, the thing holding AI back. But now, with tech like the Pollara 400 and new standards like the UEC finally showing up, is the network finally ready to keep pace with the incredible future of AI? It sure feels like we're taking a giant leap in the right direction.